as well in his book, Jesus Christ, Son of God. So ratio, again, is logos, ratio between two magnitudes. So for example, 1:2, or you could simply write it as 1/2. Note that the inverse of this ratio of 1:2 is 2:1, or 2 divided by 1, which is obviously 2. Proportion is analogos. It's when the ratio repeats. So for example, 1:2 is as 4:8, or 1/2 equals 4 divided by 8. They're equivalent, even though they're different numbers. You cannot have proportion unless the ratios are equivalent. Discontinuous proportion, as we see above here, has 1, 2, 3, 4 different numbers. We call that discontinuous. But Plato, in the Timaeus, makes a very important point about what type of bonding you want. At Timaeus 31b to 32a, he says, two things cannot be rightly put together without a third. There must be some bond of union between them. And the fairest bond is that which makes the most complete fusion of itself in the things which it combines. And proportion, analogia, is best adapted to effect such a bond. And the bond that he's talking about is the bond that is what we call the geometric mean. There's arithmetic, there's harmonic, but it's the geometric mean that is the key to nature. And that's where the golden section comes into play, because that is the geometric mean of all geometric means. So continuous proportion involves only 3 different terms. So we could have 1:2 is as 2:4. Here, notice 2 is repeated. So 2 acts as the geometric mean between 1 and 4. Well, what does it mean for something to be the geometric mean? Well, if you have 3 numbers, let's just say they're A, B, and C, and B in the middle is the geometric mean, it simply means B equals the square root of A times C. Well, 2 equals the square root of 1 times 4, because 1 times 4 is 4. So 2 is the square root of 4. The square root, for those of you who have any kind of phobia about mathematics, is simply the number which multiplied times itself gives you the number that we're talking about. Okay, there's only one way a magnitude can, with a single cut, get proportion. This is the key now. This is known as the golden section, or what the ancient Egyptians called the primordial scission. And it immediately gives proportion. There's no other way to do it. Imagine a line cut into 2 segments. We've already seen one shorter, one longer. Because if you cut it in half, the whole line will be to one of the segments as 2:1. But the 2 segments will be to each other as 1 is to 1. They're not equal. And so you don't get proportion. But when you golden cut it, it is the divine's way of immediately getting some oomph in. And notice it's an asymmetric cut that leads to proportion. It is not bilateral symmetry. You don't cut it in the middle. You cut it off center. And as you'll see, ultimately, if we can get this far, the middle way is not in the middle. It's not in the center. It's off center for very good reason. Okay, so we'll call the whole line the greater, the shorter segment the lesser, and the mean is 1. And that's what happens when you have phi here, and phi, which can be written as 1/phi as well. So here we have it. Now I've reversed what I had earlier, but this is more typical in terms of if you're a sculptor, Michelangelo and the ancient Greeks, what they do is they take the block of marble and they'd use their 3-pronged calipers. They'd mark where the navel is. That cuts us in the golden cut at the navel. Now I've measured students for 20-some years, subjecting them to getting their height and where their navel's at. And I find that the majority are in Fibonacci approximations, or what's called Lucas, because that's how nature works. We're like the plants and the other animals. It's just simply how nature works. So again, just simply put, here's the father, here's the mother in this case, now here's the geometric mean between the two. So the greater, the lesser, and here's unity. The original whole embeds itself. That's why the Father becomes the Son. Or, well, you can figure that out. Okay, so here we have the one in Plato's indefinite dyad, and this is it. Their product is 1, their difference is 1, there's no other number. When you take its reciprocal, you get both those things. And so we can skip some of this. This is how nature works with utter simplicity, economy. The evidence is that the entire universe is fractalized, as I've already said, from top to bottom using this golden sectioning process. And it is both fractal and holographic. It's self-similar. It's scale independent. No matter what level you're at, you'll see the same thing. That's why man, know thyself. You figure out yourself, you know the entire universe. It is how the Hermetic maxim is embodied in nature. However, phi and phi, the greater and lesser, are irrational. They're incommensurable. They cannot be expressed by two whole integers. Their decimals are endless. Hence, the divine proportion gets expressed through whole number approximations, and that's where Fibonacci's come in. You begin with 0 and 1, and each new number is the sum of the previous two. And as you get higher, you begin to realize, well, right away, 3 divided by 2 is 1.5, 5 divided by 3 is 1.666, 8 divided by 5 is 1.6, etc. And it asymptotically, we'll see in a second, it moves. It is drawn towards the golden ratio, which is the divine pulling everything towards itself. So you take a pineapple and you look at the rows in it. You have 13 in this one, 8, and then 5. The more vertical will be the higher numbers. Pick up a pine cone, you have the secret of nature right in your hand. Depending on the kind of pine cone or its size, in this one you've got 13 spirals going around this way, and you've got 8 going the other. You may find 8 is to 5, you may find 5 is to 3. Sometimes you'll find Lucas, but they're unusual, they're seldom. There's something about the Lucas is more pristine, it's more perfect, it's closer to the golden ratios. We don't, maybe in question time I can explain that to you. Okay, I'm going to skip some of these because we'll see it. A picture is worth 1,000 words. So here is the golden ratio, big phi in the limit. Here you've got 1, you've got 2. So between the 1 and the 2, 3 divided by 2, 1.5, you see how it moves back and forth and keeps getting closer and closer, above and below, ad infinitum, never stops, merging into the golden ratio in the limit. Now, what's significant about this for the student of ancient wisdom? It had already been established theoretically that the golden mean, as we already saw with El-Nashi, taken to the third power, assists in solving the otherwise most difficult problems of physics across the board. The component quark masses, which make up the elementary particles, as you're going to see, are functions of it. The fine structure constant of nature is based upon it. As El-Nashi pointed out, it's like a musical ladder. They're all rooted in the subtle mean and its golden source. So here are the various quarks. And it's interesting, at one time, bottom and top were called beauty and truth. Now, in normal physics, you simply find up and down, but these you also find. And notice they're all functions of the golden ratio. And, well, it's good enough. This was apparently an important feature of the ancient wisdom as studied by Plato and his teachers, the Pythagoreans, and encoded throughout the ancient world, for example, at the Giza Plateau, in its temples and pyramids near Cairo. This same mathematical principle was used in the proportions used in the Great Pyramid, the meridian triangles, we'll see, and the angle of the ascending passageways and the descending passageway, they're all 26.5 degrees. That's how you get the golden ratio. Remember I asked you to kind of keep an eye on that 26.5 degrees? Okay, so here I am in Egypt. It's nice to see there's not just camels, they got the horses too. And here I'm at the base of the Great Pyramid. Now the Great Pyramid has been stripped of its casing stones to build Cairo. However, on the base you will see that the casing stones are still there. Here I'm in the king's chamber doing some of my own measurements of the king's coffer. But notice you can look down and you can see the angle involved here, and you can figure this out. It doesn't take a genius to figure this out. It's there. It's still there. And here's what we've got. If you take the meridian triangle and cut it in half like this, so you get this guy right here. If this is 1 out to the outside, this becomes exactly phi, and this is the square root of phi, as we saw earlier in that diagram that I had done. In the Temple of Man, Schwaller de Lubitsch points out the golden section is not a product of mathematical imagination, but the natural principle of, very important now, the laws of equilibrium. You'll see why this is important later when we come to the Mahatma letters. Now, Alexander Badawi studied over 50 temples in Egypt and discovered they are designed using Fibonacci numbers. And he documented this in this incredible, very difficult to get work, Ancient Egyptian Architectural Design, a study of the harmonic system, which was published in 1965. Now, in Schwaller de Lubitsch's book, you'll find here, you'll recognize these as the Fibonacci numbers, and 0 would be here. 2 would go up, well, actually go 0, 1, 1, 2, down like this. These two would be combined to start the Lucas series. Now, this is the most amazing series of all. And this is why your very sacred number in Theosophy, number 7, is right here. Because these turn out to be the powers of the golden ratio and its reciprocal, phi and phi, bonded together to infinity and subtracted alternately, and they give us the whole integers of nature right here. It is absolutely incredible when you see it. Now, geometry in Egyptian art, we see with Kjelland, Elsie Christie Kjelland. We'll notice here, and by the way, I gave this particular slide when I went to Odessa in the Ukraine for a mathematics conference on the harmony of mathematics. We're bringing back into Euclid and into the studies, academia, the significance of the golden section. On Egyptian reliefs and sculptures, we find lines and points giving evidence of geometrical construction. Measurement indicates that the golden section was above all the means the Egyptians used to create the divine order in the pictures and sculptures in which the gods may dwell. This was carried over, another book by Kjelland, Geometry in Greek Art, and carried over even into Norway and the Scandinavians, the Vikings, building those beautiful ships, and then later the stave churches. Now here I'm in the ascending passageway, the Grand Gallery actually, going up to the King's Coffer. 26.5 degrees of ascent. 26.5 degrees down to what Edgar Cayce called the upside-down chamber. This is out near the Sphinx, the Valley Temple. They've never been able to figure this out until Robert Temple came along. And in his book on the subject, he measured this and figured out it's 26.5 degrees. It doesn't go anywhere. It's simply a model of the key of getting the golden ratio and how nature is working. The other thing is, Temple, studying old pictures, realized that on the back of the Great Pyramid on the summer solstice, a shadow is cast by Khafra's pyramid onto Khufu's pyramid that is at the 26.5 degree range. Madame Blavatsky made it clear that in the initiation into the mysteries, the secrets of proportional symmetry were revealed to the initiate. And of course she maintained that Plato, as we've already seen, was the interpreter of the world and that the Pythagorean philosophy was essentially one with theirs. But notice this, from The Secret Doctrine, Volume 1, in the 1888 edition, page 208. Now, these are her italics. Look at this. Now, I summarize it first. Most significantly, it was, and I put this in, but it is the golden proportional symmetry that was revealed